been in Santa Barbara for about 3 years now, and this meetup was one of the first kind of like instances of Santa Barbara community that I got to engage with, which was really cool. I was pretty early in learning how to be a developer, and I just think it's awesome that we can all get together and share notes and feel like we're not, kind of just doing our own tasks or work in isolation, but we can kind of like come together and share ideas. I know I've been to a lot of really awesome talks. There's a really cool Bitcoin talk, I think an Elm talk actually that first got me onto Redux and functional programming. Pretty cool event at Procore, which I still think is the meetup.com cover photo. And yeah, lots of great events. So grateful to Tim for putting it together. So yeah, what I wanted to talk about today is really comes from my own experiences implementing React Redux applications. I think Redux is one of the coolest tools I've worked with as a developer, and I've really built a lot of my short career around Redux as a technology. I think it's really powerful, it's really elegant, and it is really unfrustrating, I think, compared to other ways of developing software. And really, my goal for this talk is to hopefully inspire people to be more interested in Redux, interested in the kind of pattern and the way of thinking, because it definitely is very different from a lot of other web development frameworks. And hopefully just build cool stuff with it, do it personally at work, whatever you're doing. So, what is the agenda for today? So really, I want to do three things with this talk, and I think I'll feel successful if I have. The first is to really help, kind of explain Redux kind of from an abstract or higher level, just, how it works, what's the pattern behind it. Second, to kind of position Redux within the React ecosystem. React is a really exciting technology, but it also has a massive, massive base of users and followers, which means there's tons of libraries popping up, dying out, getting replaced all the time. And so understanding where Redux stands compared to, or in relation to the state of the art of React is really important. And then the last, but kind of most important thing I want to do, and hopefully where I can be the most helpful in terms of sharing my experiences, walking through what I consider to be the kind of ideal Redux stack. I think a kind of big thing that I didn't realize when I started working with Redux is that it doesn't work in isolation. I mean, you can obviously come up with kind of toy applications, but as soon as you wanted to start doing more advanced things that be necessitated by like a real world use case, you need some kind of helper libraries and utilities around it to kind of make it actually function in relation to the rest of the internet, for lack of a better term. So yeah, before I start, just so I can kind of level set, how many people here have used React before? Cool. How many people have used Redux? Cool, awesome. Okay. And how many people use Redux at work? Okay. Wow. Intimidating. Okay. I hope I don't get called out too hard. Well, that's great though, because I feel like, frankly, I'm excited to learn from you and to hear your questions. And hopefully this can be more of a dialogue than me just kind of sharing what I've done. But on the topic of what I've done, just real quickly to kind of introduce myself and place a little context. So I've been a software developer since 2014. Before that, I had actually had no like formal software development experience. I don't think I'd actually written a line of JavaScript until then. But I was working in finance and decided that I was really passionate about creating software and user interface in particular. So I left that career path. I took a year off and basically taught myself how to code, not through boot camps or classes, but mostly just through tons of tutorials and documentation. And then I founded a startup here in Santa Barbara in 2015. The company was called AgePath, and then we pivoted a little and became just Path. And yeah, it was an amazing journey. We were acquired last March, so almost a year ago today. And since then, I've been a software engineering director at Digital Airstrike, which is a digital marketing company based out of Scottsdale, Arizona. A really fun fact is the actual like primary application that we developed, which was a chatbot system, was actually demoed to this group before it was released, like 2.5 years ago. And that ended up becoming the basis for our entire company. So that was kind of like a sneak preview, I guess, that Santa Barbara job. So yeah, on the topic, a lot of what I'm going to talk about today, I'm going to use a demo application to kind of show some of the principles. And that that's what we call our engagement panels. So our product started out as a chatbot system. We're actually releasing a week from Monday, a week from today, oh my God, a whole new version. And that's kind of the basis for a lot of the demos I'm going to be showing. Everything's been written in Redux. We started development on it maybe like 4 or 5 months ago. Luke, who's in the crowd, has been working with me on it. And yeah, I'm super stoked to be sharing it and hopefully can demonstrate some cool things we figured out along the way. So real quickly, I'll just show you, this is the demo application. So the kind of app on the left is our initial chatbot product. It's pretty similar to like Drift or Intercom, if you guys have seen that. And then what's on the right is kind of the rebuilt application. It's what we call an engagement panel. So the idea is it's got a chat system, but it also has kind of like an operating system based on cards, where each card is kind of a self-contained React component that can present data and also be interacted with by the user. You know, so it has foreign capabilities. Each card can actually interact with third-party APIs. It's a pretty dynamic and flexible system, and I think what I like about it is it really could only possibly be made in Redux. And yeah, so hopefully it'll provide a good kind of way to demonstrate some of the things and ideas I want to talk about. So yeah, this section I'll probably go through faster than I was expecting because most people here know Redux pretty well, but Redux at a high level. So, you know, this is kind of my take of Redux just from being a practitioner for a couple of years. The way I really think about it is it replaces stateful components with a completely different paradigm where the entire application is just one big function that takes state and returns user interface. That's how I've always thought about it, and that kind of mental model has served me really well. So everybody knows, I would hope, this formula then. This is kind of the main reducer formula. It's really simple. You have a state and an action. You have a function that takes a state and an action and returns a new state. And kind of the key behind this is that state is immutable. So you're never taking the old state and returning a copy of the old state with something updated. You have to return an entirely new state. And that's kind of the principle that you know, Redux uses and then React uses to create diffs off of that state and determine what actual application user interface components update. Most people have already probably seen this as well, which is kind of the classic or idiomatic diagram of how Redux works, right? So I like to kind of think about it starting at the data store at the top right. And this kind of arrow at the bottom right, frankly, is where most of my application code lives, which is the idea that your application, your React components are essentially, your whole UI is just a composition of React components that translate stored into DOM. And then what Redux really does is everything else. So it takes actions that occur in the DOM and then interprets those via the reducer as modifications to the state, though you're not actually modifying state, you're reducing state and returning a new copy of state that has been. Is all of this pretty familiar to everyone so far? That's nods. Okay, cool. So yeah, I mean, this is really the crux of what I want to get across today, is that I think in order to really practice Redux development, you need to shift from how you think about an application. And I think this can unlock, what I love most about Redux is it unlocks new ways and new types of UIs that I think weren't even imaginable a few years ago, when everything was focused on, you know, let's call it the Ruby on Rails model, where you had, you know, all these, you know, MVC, all these different views, and each one of them kind of has to ping the server for data. Or even the pure React model, which each component, again, kind of has its own internal state. Redux makes it so that all it is your whole app state and UI. And I think there's something really powerful about the idea of decoupling your application state from the user. And I think there was a question we were talking about earlier, which is how do you structure your state once you've kind of untethered it from the user interface? And I think that's something that I hope to address in this conversation, because it kind of opens up some pretty interesting opportunities. So yeah, with that, I'll give a quick demo of the application that I'm walking through today. And I think like a big takeaway I hope people can get from this talk is, I actually think the most important decision that a Redux developer makes is what their state looks like, what the structure is. and the shape of it and how you're storing data, what data you're storing, how it's related to each other, etc. So, I'll show you the demo. Cool. So yeah, this is the demo system I want to walk everyone through today and use as kind of a basis for the talk. So this is what we call the engagement panel. It's designed to be an embeddable widget that goes at the bottom left or bottom right corner of customer websites. So it kind of lives inside of an iframe. You have a pretty simple install code. You drop it on your website, and then this thing will effectively render every time someone visits. So once it's expanded, the idea is that really everything is about compositions. The engagement panel is a composition of different cards that are effectively user interface elements, and then different views that are each different stacks of cards. And the idea is that everything here is flexible, so each customer can create their own set of views at the bottom, can create all their own cards, and then choose how to arrange them to the end user. So what I like about this in terms of demonstrating Redux is it's completely untethered from what people think websites are, right? Because we're in this kind of separate little iframe box, we don't have to worry about views, we don't have to worry about conventional routing. We can really do whatever we want. And so that also, like, that flexibility and degree of freedom means we had to be extra thoughtful about how we structure the Redux state. And so you can actually see on the right, this is Redux Dev Tools. How many people have used Redux Dev Tools? So, I mean, what was that? Yeah, so Redux DevTools are absolutely amazing. They let you see the entire sequence of actions that's occurred since you started with your app. They let you time travel. They let you inspect individual actions, inspect your state at any given time, and also see a GIF, which is my favorite feature, of your current state versus the state on a previous action. But what I want to show everyone is the state that kind of underlies this, because it's pretty interesting. So we haven't been rigid at all about like each view is this fixed kind of DOM hierarchy. In fact, every view just exists loosely in a database style collection, which is part of the normalized state. And I'll go into this later in the conversation as well. But effectively, you've just got these 6 views. So you've got the home view, the trade-in view, the reviews view, the text us view. And all I'm doing when I navigate the application is jumping from one of these views. Now, each view in and of itself, if you inspect it, is actually itself just an array of different cards, right? So this home stack view has 3 cards: the promotions card, the gallery card, and the hours card. And effectively, when customers set these systems up, they create all of their cards, and then they structure them into stacks, which are the different views. So that's kind of where all the, I'd say, like, meat of the state lives. We've also got individual cards, right? So every card in the view has different characteristics. So if you look at the promotions card, for instance, this has props that then get passed down to the underlying React component. So it's got a huge image, a title, a body, and some buttons at the bottom. Obviously, there's a ton of cards that are used throughout this application, but you can see all of them in one place here. In addition to that, we've got a pretty powerful form system that I won't dive too deeply into, just because I think it's outside of the scope of this talk, as well as a centralized lead model, which stores all information that users might enter as they interact. So, you might come in here and say, hey, my name's Sean Emmer. And what's really powerful about Redux, the React in general, is I'm actually able to capture data on every single keystroke. So, like, I have a constantly updating lead model based on individual keystroke level interactions. Now, what I really love about this, and I think you couldn't do with pretty much any other system, is the fact that it's all centralized. So I'm sharing a single state definition of who's interacting with my tool across all their different interactions inside of this application. On top of that, I've got a couple other neat things. UI just kind of manages state, and then what I think is really fun and interesting is a router. So we don't actually use any of the built-in browser routing system. We have our own kind of router and location history. So as I jump around from view to view, my router is firing, and then I can press back like I could in a web browser all the way to the very beginning. So that's a quick demo. And like I said, we really wanted to flex as much as possible with Redux when we were building this and take advantage of the fact that Redux really does kind of decouple you from, connecting your UI to your state and really adhering to any browser norm. So with that, I'll jump back to. I'll kind of pause there. Any questions or thoughts as we go on before I get into some more interesting stuff? Yeah. Yeah. So what we do is we actually map out all the dependencies in terms of cards and views at the very beginning, but the whole payload is pretty small. But yeah, we use create React app. Everything gets bundled by Webpack. I'm doing hot reloading now, but we obviously minify and compress it all down before pushing to production. Cool. Yeah. So we're not keeping track of the states. We have kind of an internal view system here. So if you recall in the entities, I have all these different views in the application, and the router is just keeping track of the different views that I've triggered. We don't, in terms of internal application state, we don't keep track of all state changes. Obviously, Redux DevTools does that, so if we want to time travel, we can, but we realized we didn't need that for actual production instances. That's, oh, Redux React, not vanilla React, rather. No, and that's kind of the big part of this is that this isn't embeddable on the customer website, so we're not taking over the URL. We're kind of like an app running within the customer. So that's kind of why we had to write our own router, because most of the app router or traditional router systems, like they do work off the window. Um, and also this is like frankly a lot. It just kind of covers our specific narrow use case. Um, cool. Yeah, can jump back in. Um, okay, so yeah, this next part of the presentation was frankly, I think, the hardest and most required the most thought in terms of kind of. I think the hardest thing about being a React and JavaScript developer is kind of placing the tools you currently know and understand in the ecosystem and deciding when it's time to kind of update the tools you're using, when it's time to go with the new shiny thing, or go with something that you know a little better in terms of like a given use case or development task. And so I really wanted to ask myself, from what I've learned using React, and I also use GraphQL a fair amount on side projects, um, like where do all these pieces fit? What tools are appropriate for what project? And so I had some fun, a little too much free time at work today, going through and figuring out all these different tools that come up over the years. Does anybody think they can name all of them? Yeah. All right, we got Flux, RxJS, Redux, Hollow Client, which is awesome if you haven't used it, GraphQL, Relay, and then that's hooks. That's not official, but I just thought it was it's really daunting, and like especially if you're given carte blanche on a greenfield project and nobody's telling you what tool to use. I think one of the hardest things as a React developer is deciding what tool is right for the job. And then um, so I kind of thought a lot about this, and really, in my mind, there's three kind of flavors of how you manage React state, and that's the best mental model I could come up with for how to kind of rationalize all this. And so the kind of simplest is what I would call imperative React state management. And that's kind of, best exemplified by like using the fetch API. Some of the most simple examples you see out there are based on this. They kind of usually revolve around lifecycle methods, like when the component mounts, you fetch data from a third-party API or from your API, and you then, do a component. You then pass that to your component, and if you need to refetch the data, you'll do a component did update. You might do a component did unmount. You basically use the right life cycle to determine when and how to grab the data. The second flavor, which I think is pretty rad, and honestly, I'd love to do a whole talk just on this, is declarative React state management. And so I think like the idiomatic example of this is GraphQL, and specifically either Apollo client or Relay. And so these systems are pretty different and pretty unique in that effectively the component declares all of its data dependencies, and then these client-side tools will just kind of handle fetching all that data from the API. Now, this is harder in some instances than others. With GraphQL, it's really, really easy because GraphQL kind of automatically handles relationships, pagination, filtering, sorting, etc. And so that's definitely been a pretty hot technology. It's gotten a lot of refreshing and updating every year. And then the last paradigm would be Redux, right? So that's, or would be functional React state management, which I think Redux is the best and simplest example of. And that we've already talked about is kind of this idea of an immutable state that your user interface is a functional representation. And so in terms of like when each of these are useful, I'd say that the imperative flavor has a really low barrier to entry. If you're trying to do a proof of concept or just demonstrate, that a component can, render a certain, set of data from an API and you just want to get something quick and dirty up and running, great. It also runs around very well established standards. I don't think anybody would have a hard time figuring out, how to do a fetch request. You just go on MDN docs and figure it out pretty quickly. I think the hard part is that it handles complexity poorly. As soon as you have to do a series of fetch requests or, refetch, not only is it kind of just 4DX and just kind of messy code, but it also probably isn't going to be the most efficient solution. You're going to end up hitting your API more times than you need to and writing more requests than you want to. I think declarative is really exciting from a front-end development perspective because it requires very, very limited client logic. All you do is declare your GraphQL query and it will go ahead and pull everything you need from the database. On top of that, the tooling is really awesome. I mean, the way they handle things like caching and optimistic updating is pretty impressive. But the biggest challenge here, and especially for those of you working in a professional environment, is that you have to have a GraphQL server. And it's not the easiest thing to convert an existing server to GraphQL. And obviously you need buy-in to build new servers in GraphQL. So even though the client's really easy, it basically offloads a lot of that complexity to the server side, and it's not necessarily an easy migration for legacy systems. And then the last flavor is functional, right? And what I think has gotten Redux so much purchase is the fact that it can handle the messiest server situation. It's pretty agnostic to what's going on in the backend. It also, I think, is a very, very simple and elegant model for handling complexity. So at the end of the day, as long as your state is well structured and you're following the kind of paradigm of sending your actions to your reducers, it can handle an enormous amount of complexity that would kind of give these other paradigms a hard time. Now, the downside, because there's always a cost, is it requires a lot of infrastructure on your client, right? And I'm not talking about performance, I'm just talking about setup. You got to set up your store, you've got to structure your reducers, you have to connect all of your components to the Redux store. And so there's definitely a cost, and I think if you're trying to get a quick proof of concept up and running, it might not be the most appropriate tool. But if you're trying to build a system that's more complex, I mean, it's definitely worth the upfront investment. So in my mind, and this is something that I personally face a ton, both with work and kind of my personal projects, is deciding between the second two options. So when do you use kind of a declarative GraphQL solution like Apollo client or Relay, and when do you use Redux? And I thought a lot about this question, and I think there's times and places for both. I think most projects can work with either one. You can accomplish what you need to, but sometimes it's probably easier to use GraphQL, and sometimes it's probably easier to use. And so I think GraphQL is ideal for read-intensive stuff. It's also really performant, right? So like I said before, the caching system and the way it handles relations really reduces your server load and reduces the amount of data you need to pull. that's why it was initially developed by Facebook, actually, was because they wanted to optimize for mobile performance. And it works great as long as your state and your components are tightly coupled. I think as soon as your state and components are not tightly coupled, as soon as you want to share state across lots of components, that's where Redux really shines. And so, like in the engagement panel I just showed you, when you have a highly interactive component where state's being shared across different components, and this is an important thing too, when you're kind of dealing with a lot of client-side state, I find that Redux really shines. When your state is mostly stored on the server, GraphQL is great. Now that's not always going to be the case. Apollo Client just released a new version that actually has some pretty cool client-side state utilities. But for now, Redux, I think is much better at managing a state that's kind of centralized and quickly evolving inside of the browser. All right, so now I'll do a quick and simple demo. This is just kind of a fun little aspect of what we built that I think demonstrates stuff that you can do with centralized state that's a little bit harder with kind of just for tightly coupled state. So we built this pretty neat form system that I was showing you earlier. So let's say, I'm going to use loose names. He's the only person that has a full name for it here. So let's say I go in here and update this. Pass the phone number validation. So as I showed you guys before, the React or the Redux state here is updated, on every keystroke, right? So I've got this updated data with Petrucci, this is his phone number. And so what having a centralized store lets you do is I can now go to a different component, and I'm coupling all the forms in this application are bound to this same read state. So, by the way, this is a cool thing we'll dive into later. So this is a vehicle trade-in estimator. This uses Kelly Blue Book and will tell you the value of your car. So this demo is for like a car dealership. And so you can see now that I got to another form, and the form system is always referring back to the same read model. So because I've got this centralized read model, this form is actually able to pull all the read data from before, and now this person doesn't have to fill out their information a second time. They can just move to the last step. And so that's an example of how a centralized kind of read model can let you share data across different application components pretty easily, right? And I was able to do that without ever having to make a server request. This is all just data that's kind of living inside of the React. That requires a third-party API. Okay. So yeah, I'll kind of pause there. Have you guys, ever implemented this pattern where you've got this kind of shared state across different views or different components? Is that something where you guys really help? Okay, I'm excited about this. Alert, alert, alert. I didn't mention React hooks, how in March of 2019 could I not have a React talk about hooks? Okay, so I, like hopefully most of you, am really, really, really excited about hooks. I think they're going to make all of our lives way, way easier. For anyone who doesn't know what hooks are, if you've been living in a React cave for the past 6 months, hooks are basically a set of effectively side effect utilities that let you implement side effects inside of React components that can stay as functional components rather than having to implement them only by turning the component into a class and using lifecycle methods. And there's a whole kind of menagerie of hooks out there, some of which are officially supported, some of which aren't. But me as a functional programming junkie, what I'm really excited about is that React hooks introduce kind of functional paradigms into React components. So for state management, you've got user. For side effects, they've got this use effect model. And so what I think is really cool about hooks is they're going to let people get like a lot of the benefits that you used to only be able to get from Redux inside of kind of regular components. So now that first kind of imperative model I was talking about, where you're stuck with lifecycle methods and fetch, now you're not just stuck with that if you just want to keep pretty simple components. You can access some of these more powerful patterns, even if the component's simple using hooks. It also means we'll never have to write class components again. So, I've been actually talking about having a class purge where we just go through our entire code base for like a few days and get rid of every class. Well, you know, I'm anti-authoritative, I guess. First, we need to write a test. Um, but yeah, I mean, more generally, I've been following a lot. You know, if you go to pretty much any library on GitHub that's got, you know, a fair following, go to the issues section and type in hooks. There is like a months-long debate going back and forth about how to transform that library or hooksify it, right? And I'm really excited about it. I think we're in very early days, but the way I see it, it's not like hooks are going to replace everything we currently do. It's more so that they're going to like cut up the way and like kind of allow us to break apart the way we currently do things and kind of grab little pieces of it that we like and implement them as hooks. I think, and I'll talk about how this is going to happen with Redux or can happen with Redux capabilities, but you know, in generally, I just think it's going to not necessarily make us throw what we're doing out, but it's going to make us rethink how we do things because we're no longer hampered by class components and hampered by lifecycle methods. So yeah, I'm really stoked. I've already started using this in my GraphQL stuff. But from a Redux perspective, what I love about hooks is it's basically taking patterns that if you wanted to take advantage of, you really had to use Redux, and now letting you use them in kind of much simpler components. So like there's a lot of stuff that used to be magic in Redux that's now trivial in hooks, right? So Redux used to have this central store that was this kind of like amazing thing that was, you know, super novel, and now anybody can create a store of their own with just the use context hook, which has existed since the context API. There's the reducer pattern, right? And so now what's amazing about hooks is you can implement reducer style kind of like action responses on the state of an individual component as opposed to just this kind of massive centralized state. And then what I'm probably most stoked about is we like won't have to write higher order components anymore, which is really, if anyone's done it, it's really, really hard. And now we can just use the use effect hook to achieve pretty much the same things. So yeah, fire it up. Okay, so yeah, the last but maybe most important thing or most hopefully novel thing is I just want to talk about a couple of the tools that I've used with Redux that I think make it way, way easier and solve some of the most common problems. So this is kind of my personal Redux stack. And so I think the problem at the end of the day is web applications introduce scenarios that this simple formula or simple reducer pattern doesn't always solve for. And I learned this the hard way, and I think the kind of last time I built a major Redux application, I just tried doing everything in just Redux because functional was so cool. And you know, I think that you need to recognize that there are certain things Redux isn't good at, and kind of augment that with tools that help make what needs to happen inside of your application. So there's Redux on its own, but then there's the real world. So the first thing I want to talk about is asynchronicity. Effectively, in the real world, not everything's synchronous, and we need to, most importantly, make HTTP requests and wait for the server to respond. And Redux deliberately has no built-in side effect model. You know, everything about the functional paradigm is that side effects are bad; they should be avoided at all costs. Problem is, you know, anything that's asynchronous can effectively be considered a side effect. I'm going to be kind of opinionated here. I think chunks are a horrible way of handling side effects. I've had a pretty bad experience with them. I think the reason I'm not a fan is because you're effectively shoving side effects inside of your actions, which isn't where they belong. And so the solution I found, which I cannot speak highly enough of, is Redux Saga. So how many people here have used Redux Saga? Okay, well, pretty light. You guys are missing out. Okay, so Redux Saga is amazing. It's basically gives you a really powerful but really simple way to manage side effects while still keeping the same kind of Redux pattern of simple actions and reducers that translate those actions into state update. So what are sagas in practice? Effectively, they're doing two things. One is they move these side effects to a completely separate thread outside of your synchronous Redux kind of action reducer cycle. And so That means that your asynchronous action can occur, and then when that asynchronous activity is done, it can redispatch an action to your main Redux thread with whatever data was retrieved or whatever side effect happened. Now, the way they do this, which is really, really elegant, is they use ES6 generator. Because anybody here use generators before? Okay. How about async await? Okay, so generators are like async awaits, like less user friendly but more powerful predecessor, uh, and they work particularly well with sagas. But effectively, they achieve the same thing. They allow you to take actions that are asynchronous and have your JavaScript code treat them in a synchronous fashion, where in the same way with async await, you await each next kind of element in your stack of actions, or in your stack of code. And in generators, do the same thing, but instead of awaiting, you're yielding to the next function. But you can think of them kind of mentally the same. And that's perfect for Redux Saga because effectively what you're usually trying to do with a side effect is a series of asynchronous actions, right? You're trying to do, a sequence of HTTP calls. You're trying to do an HTTP call, then store it in a data store, and then dispatch an action. And so sagas are, I think, the ultimate solution for this type of activity. And because it lets you asynchronously do these things, not only can you asynchronously conduct your side effects, but you can also asynchronously dispatch actions back to your main Redux store. So, and the last thing that I think sagas do that thunks don't is they keep your actions really, really simple. Your actions can still just have a type and a payload. So, let's talk through the demo. So, I'll walk you guys through. Unfortunately, this demo doesn't appear to be working right now. Oh, it's because I'm not on the internet. Well, this is supposed to do an API call and retrieve some results. Unfortunately, it's not working right now, but I can still show you the code that makes it happen. So go to VS Code. This is the Saga, okay? And so, yeah, let's do it. Okay. So effectively what Redux Saga does is it gives you a series of effects that let you conduct asynchronous actions. And each effect lives inside of a generator function, and each effect is yielded to, which is the mechanism that lets those effects run, asynchronous effects run as a synchronous sequence. And so the saga, when you create a new saga, is effectively creating a new thread. So this take every function is effectively saying that I want you to take every action of this trade-in value type, and I want you to handle that action with this saga, right? And so get trade-in value, so you guys can see. Yeah, that. Okay. So in this example, what's happening is we're basically going to make an API call, and using a bunch of data from state, we're going to retrieve data from the API, and then we're going to store that data back on state. So the way this all happens, it's all initiated, as in any good Redux application, by an action. And this is actually a pretty simple action. So this action doesn't even have any data. All it is a type. It's saying, hey, dispatch the action saga/get trade. The saga we've created, effectively taking every instance of that action and then running this saga code above. So that's this generator function. Okay. So the first thing it's doing, and let me take a step back. A saga can do a bunch of stuff. It can put actions, so everything goes through effects. It can put actions to your Redux store, so that's what this put effect is. It can select data from your state, It can do, there's probably like 5 or 6 actions. There's like a delay effect, there's a take every effect. But we'll focus on these two, because these two do most of your work for you. So the first thing the Saga is doing is just clearing my state. So it's putting out an update lead action and removing the current price from my state. The next thing it's doing is pulling a bunch of data off of my state that it needs to make this HTTP request. So I'm grabbing all of this lead data off of my state. So I'm grabbing the year, make, model, trim, mileage, and condition of this vehicle that I want to get the price of, and I'm just yanking that off of state. So this is using the select effect from Redux Saga. Then I'm making an HTTP request with this data. So I'm yielding to a subgenerator, which is tasked with making the request to the end API with all of this data that I just selected off of my state. I don't want to get too into the weeds here, but effectively a subgenerator is just like another generator function. So it lets you refactor out your generators into subgenerators so that your code doesn't get too long. So then I get back this prices data from this HTTP call. I then find the price I care about. I destructure to get the actual variable. And then when I'm done, I store that data back on my original state. So I'm just updating my lead model with the trade-in price I got. So, this looks like a lot, but we're actually doing something pretty complex, and we're not muddying any of the kind of Redux actions or reducers at all. We're just kind of handling it all in a separate thread. And it's all being handled really elegantly in terms of being run as a sequence of async actions. So this is, the example I wanted to show, but Redux Saga in general it helps you effectively kind of take something you want to do on your state, do it off to the side, and then when you're done doing it, redispatch the results of what you've done back to your Redux state or Redux store. So it's kind of, in my opinion, the ideal pattern for handling HTTP. It also has a ton of pretty powerful utilities. So something that I'm not showing here, but it's very cool, is it handles WebSockets really elegantly. So it has this concept of channels, which let you effectively translate socket events directly to actions. So it makes it pretty easy to wire up your Redux store to WebSockets. And then it's also got, other utilities. So there's take every, but you can also create channels to kind of buffer the different actions that come into your sagas. There's really a lot of power user features, but for most scenarios, like these 3 effects are going to get most of what you need. Yeah, I'll kind of pause there because this is probably the most technical part of the conversation. Any questions? Yeah. Yeah, so the approach I take for branching is effectively, and this is again why I love sagas so much, is you can spawn new sagas from your root saga, right? So maybe everything starts out with a top level saga, and then based on the results of your second yield in your saga, you'll get some data back, and then depending on that, you can then dispatch another action that will spawn another saga. And so this example is a simplification in that it's just kind of structuring everything as one sequence, but because sagas themselves can dispatch actions, they can then trigger other sagas. So there's this really powerful kind of nesting character. Yeah, I'm a huge fan. I can't say enough positive stuff about this. Any other questions? Yeah. Um, no. thankfully, I've been the one who's gotten to make the decisions around this, so nobody's told me to take a look at observables. But yeah, I've looked at RxJS, but I haven't used it. Yeah. So I mean, it's all in a try catch, so it runs into the regular error handling. I think obviously in the nested scenario we were just discussing, I think you would have to come up with more sophisticated failure catching mechanisms and build some specialized logic around that. In terms of something like this, like in a strict linear saga, I don't update the actual state until the very end, right? So it's kind of like you start the saga by pulling the data you need from state to conduct your operations. You conduct your operations, and then only at the very end, if everything's succeeded, do you then actually send the data that resulted from those operations back to state. So because of that, like, and this kind of is a testament to Redux, because state's your single source of truth, you don't touch state until the very end of the saga, you're kind of safe. And obviously, if you're touching state in the middle, you would need to build some kind of custom logic to handle failure scenarios or kind of like unwind, intermediate state updates. Actually, my favorite thing about this is I built a toast system in sagas. So this saga will spawn a toast that says there's been an error and then kind of pop that up. Yeah, yeah, that's a good question. I think that a big part of it is minimizing the amount of state that lives inside of the saga. And if you do need to use state, you continue to pull it from the Redux store. So I think it's this select effect is really important, right? So yeah, I mean, I think that's probably the first step is just keep state out. If you ever need to, like, you shouldn't be storing state in your saga. You should push it to the store and then pull it back when you need it. So I think that's probably the biggest protection against that. And the other thing is just minimizing the use of sagas to actual side effects and stuff that can be handled synchronously should just run through the regular action release cycle. But I mean, yeah, obviously this can definitely be abused and requires discipline, as does all JavaScript programming in some regard. Thanks, that's a great question. Yeah, yeah, definitely. Actually, that's the next thing I'm going to talk about. So let's dive on in. Um, I think to answer your question very briefly, though, this state shape. Well, I want to talk about selectors because I think selectors actually inform state shape a lot. And then the second thing is denormalizing your state, so making your state look like a database. So yeah, let's dive into that. So, and I wish that API was working. Sorry, guys, but if you want on Monday, go to nonelwaymotors.com. You can see it live. Okay, so this is the second problem I want to talk about, and the second solution, and that is how do you. So, a big thing to consider with Redux or React Redux in particular is that connected components need to re-retrieve data from state on each render. So your connect function maps state to props, and those map state to prop functions run every render cycle for your. And if you look at Redux in isolation, again, Redux is very high-minded and theoretical and doesn't get their hands dirty in terms of how you should actually query data from state. And so the solution that I've found is a library called Reselect. Has anybody in the room used Reselect? Nice, okay, good. I also love Reselect. So effectively, Reselect introduces a standardized state selector, which is used to query or pull data off of your state. And your map state to props function typically will just be a reference of each prop and then the selector that that prop should use. And selectors are pretty cool, not only because they're opinionated, but because of the way they're set up. So the way a selector looks is it is an array of input functions that are the direct properties pulled off of state. And then the last item in the selector is what's called a transform function that takes all of the data your input selectors have pulled and forms it in the shape that map state to props is accepting. Oh, nice. No, I want to just show my presentation. There we go. Thank you. And so the really cool thing about selectors, or at least the thing that they go on and on about in their documentation and even have a special word for, is that they're memoized. And so what that means is that if your input functions don't change, so if the properties of state that your input functions are referring to are identical, or excuse me, equal, not identical, there's a difference I've learned in practice, then the transform function doesn't have to rerun, and you get a little bit of an efficiency boost. Now, I do want to say a big caveat with selectors is you need to be careful that your input selector values, that you actually capture those changes, which doesn't always happen with nested objects. Sorry, that was an aside. Battle scars. But I'll show you guys a quick demo of how a selector works. So in the example I was showing you, kind of last step of the trading component takes this vehicle summary. The vehicle summary gives you the make, model, year, and price of the vehicle. So that's one of the props of this component, and then those get rendered inside of. If you look at the container, as I was mentioning before, effectively in a Reselect application, your map state to props is just a list of all your props, and then the selectors that those props are using to query state. So in this example, we're using the trading vehicle summary selector. And so this example is interesting in that its input functions are very similar, but its transform functions is kind of complicated. And so this is somewhere where the memoization is actually helping. So effectively, we're pulling this trading vehicle property off of state, which if we go back to looks like this. And so what the selector does, which is great, is it's taking this data and transforming it in a way that makes sense for the props that are going to be consumed by the actual React component. And then this just gets mapped to props and the component renders it. So what's cool is in this example, if trading vehicle didn't change between now and the previous rendering of this component that's expecting to present the data, this whole transform function doesn't have to work. I can also see if I can find some of the slightly more complex. Yeah, so this is a slightly more complicated example where we've got two input functions. And so here, just to kind of get the mechanic of Reselect down, Reselect will rerun both of these and check if the value of this equals the value of the previous one. And if it does for all the input functions, it won't rerun the transform. Like I said, though, you do have to be careful because objects can sometimes be equal when you don't expect them to be. And so there are ways around that, though. You can write custom comparison functions, et cetera. If anyone's interested in that, you can ask me. But yeah, that's pretty much the Reselect pattern. Okay, so now the last thing I want to talk about, and this goes back to the question. So now that we've kind of gone through these two really powerful tools, I want to talk about, I think, one of the most interesting patterns I found in Redux. You've got to go pretty deep into their documentation to get this, but um, very cool. And honestly, I think one of the hardest and most important aspects of building a Redux application is deciding what your state shape should look like. Um, if you read the docs, I think one of the most kind of powerful things I got out of them is that your state should not look like your UI. Your UI, I mean, that kind of defeats the whole purpose of Redux, right? I was mentioning earlier, by decoupling state from UI, you give yourself a lot of flexibility, and you can do, cool things like share cards and views across different presentations of your application. And so, without anchoring components, how do we think about state? And the most interesting pattern I found is actually taking your state and normalizing it. So if we go back to the engagement panel demo application, that means is that effectively you've got kind of all your typical state, but then I've also got this entities collection, which is effectively a database. And so inside of each of these entities, I have a normalized state that shows, by ID, all the different entities that are on my state that I'm interested in. And this actually marries with the selector pattern really well, because now you can just use selectors to grab entities by their ID off of your state. And so why is this cool, or why is this important? I think what it allows you to do is it makes your state more composable, right? So now, like for instance, I've got this cards entity here, and I can mix and match these cards however I want to create any different user interface I'm interested in. And so it's interesting because data normalization is something traditionally associated with databases, but if you normalize your state, it effectively it makes your components less kind of rigid and allows you to kind of normalize state. I think there's a couple other benefits to this. So obviously selectors, having a nice pattern is great. I also think the reason it's popular is because it makes it so that your state parallels the way data actually comes directly from the API. There's actually really cool libraries that will take data that comes from like a SQL-backed API and automatically translate it into normalized data that you can drop right into your Redux. And so yeah, it simplifies the process of taking API data and putting it in your data store. And yeah, like I mentioned, the third one, it's kind of hard to articulate, but I think it does make your UIs more flexible, because now your state is normalized and less brittle, and therefore you can build a UI that's less brittle, right? Because it's not tightly coupled to what your state is. In general, if you're interested in state structuring, there's this section on the Redux documentation called recipes. It can get pretty technical, but I think it's really worth reading and will open up your eyes to different ways of structuring state in which you're not constrained or just mirroring your user. So yeah, that's oh yeah, and then I kind of already showed you the demo, but this normalized state pattern allows you to do stuff like, I have this card that lives in my cards collection here, but I'm actually reusing it in different places in my application, right? So if I go to this info view, I've got this card. It's actually referencing the same thing inside of my state. So if I'm looking at the service section here, and I go back to this section, it's the same exact card, and it's referencing the same props that are living on state. In the same way, if I partially fill out a form here and that form lives on another view, it'll be the exact same instance of that card. And so I know it's a little hard to articulate, but effectively denormalizing state makes it so that you can compose your components in a way that wouldn't be possible if your state was, set to a rigid structure. Yeah. And so this is my conclusion, and then I'll open it up to more Q&A. PowerPoint deck came with this cool iceberg slide, so I wanted to keep it. But I really do think it's true. Redux, for me at least, has been a gateway into much more interesting ways of thinking about web applications. When I came into web applications development, I was just kind of like clinging to my jQuery and thinking about DOM as this, big hierarchical mutable thing that I could, poke at and get it to look different or act differently. And Redux has really helped me rethink what an application is and really reframe everything in a functional paradigm, which I think is for me at least, has been a much better way of thinking about it. And importantly, I think Redux on its own is not enough. And it's, as you who are using this in a professional context it needs to be augmented with tools. And tools like Redux Saga and Reselect have been extremely helpful for me. And the last thing I just want to say is, we're in JavaScript land where every year there's some hot new thing, and I think it's pretty telling that Redux has been around for a long time now, and still has really robust support. Facebook hired Dan Abramov, the guy who created Redux, and he's now driving a lot of their development. So that's why you're seeing Redux patterns like these reducer, reduce context showing up in React core. And yeah, I think that things are definitely changing in React. I think it's going to be a really interesting year or two. And I think a lot of the libraries we use on a day-to-day basis are going to look very different a year or two from now because of hooks and other changes. But I think the pattern that Redux shows, that very simple action, state, proof state, that's going to be around for the foreseeable future. And so I think Redux is a worthwhile way of achieving that in more complex applications. Yeah, so that's it. Thanks for listening. Cool. Questions? I mean, I haven't. It's hard to put a number on it. I think in general, at the end of the day, it's all text data. So, I mean, yeah, you don't want to get too crazy with it, but if you think about it, like even 1,000 rows in your Redux store is less than a high definition picture. So, there definitely is a performance bottleneck, and I think, frankly, before you're concerned about storing it in your state, you should be thinking about the network implications, right? So if you're retrieving thousands of rows from your network, that's not probably the most efficient way to do it. There's probably some kind of pagination scheme you could use. Um, so yeah, I mean, I couldn't put a number on it, but it is just plain text, JSON, basically. Yeah, good question. This is actually an active area of development for us. The tool that we're implementing actually as we speak, tool and I think effective for Saga is called Cypress. Cypress is an end-to-end testing tool. It's kind of like Selenium. If like Selenium and Jest had like a modern, you know, love child, I think that would be it. But I agree that unit testing, I think it's not that you can't do it with Sagas. You can. It's just it becomes onerous because you have to start, building mock services. And so for us personally, we are kind of doing less unit testing in favor of end-to-end testing and TypeScript. Right? Awesome. Thanks, guys.